let's talk a little bit about closed curves. A curve is said to be closed if its initial and terminal points are the same. In other words, R of A equals R of B. So in other words, if I have a path, a curve that looks like this is definitely closed, as compared to obviously something that maybe looks like this. This is a not closed. Now, if this line integral is independent of path on some domain D, and C is any closed path in D, we can actually choose any 2 points I'm going to call them A and B, of course on C, and consider C1 from A to B and C2 from B to A. Then, let's draw this a little bit. I'm going to take a point, say here and here, call this point A and this point B. So based on my notation, C1 goes along this path from A to B, and C2 goes along this path from B to A. Then the line integral f dr is going to be equal to the integral over C1 of f dr plus the integral over C2 f dr, which is equal to the integral over C1 of f dr minus the integral over C2 f dr, that's supposed to be a dot, which all these are obviously equal to 0. And I think you can see that because if I go C1 plus C2, that's all the way around here and right back. So that would be f of a minus f of a from the fundamental theorem for line integrals. If I take C1 and the negative of C2, that's just saying go the other way around. Again, because the orientation is opposite in direction, this is going to be the negative of C1. So once again, I'm going to end up with 0. So, but one by one, when you break these down and look at it, thinking in terms of orientation and on the curve here from these 2 points, you'll see that it makes sense because this is a closed path. Now, this brings me to a theorem. If the line integral f dr is independent of path in a specified domain, if and only if the line integral of f dr equals 0 for every closed path in the domain. Now, simply by saying here in the specified domain, what I'm really saying here is whether we're working in R2 or if we're working in R3. I'm not distinguishing between these. So again, the line integral f f.dr is independent of path in a specified domain, either R2 or R3, if and only if the line integral f.dr equals 0 for every closed path in that domain.